This view was given particular force with the introduction of the quantum wave equation by Schrödinger and the matrix representation by Heisenberg in the mid-20s. The wave equation was introduced to describe the trajectories and behavior of subatomic particles like electrons. Without it, the behavior of electrons in the atom or diffracting through a double slit made no sense. But the new wave function presented a problem. It was explicitly non-physical, because it was, in mathematical terms, an imaginary or complex-valued object. Additionally, when evaluated to generate measurable quantities, it operated in a probabilistic manner. With Paul Dirac's incorporation of special relativity into the framework of quantum mechanics, the new field theory approach was developed to account for more than a single species of particle. However, with quantum field theory, a radical new view of the concept of a field emerged. In many physical theories, there exists a concept of a field. The idea of the field originally was imagined to have a physical basis. For example, the magnetic and electric fields were conceived to arise from a physical medium called ether. The gravitational field, when it was first described by Newton, required action at a distance. It was for this reason that Newton believed it was profoundly flawed. It was only with Einstein that the modern view of a gravitational field, described as a product of a medium of curved space-time, emerged. As we will discuss in much more detail later, with the advent of quantum mechanics, the concept of a field transcended the need for a physical medium. Mind you, a medium still exists, but it was explicitly non-physical, an abstract mathematical function that permeates all space. This new abstract understanding of the field is a large reason why Plato's idealism appears to fit well in modern physics. But this was not always so, and even today this fact seems lost in the popular understandings of the subject. I think it's safe to say that the birth of the concept of the modern field began with James Clerk Maxwell's derivation of the equations for electromagnetism. Between the years 1862 to 1864, Maxwell came up with a theoretical framework which united the electric and magnetic fields, showing that light was basically a type of wave propagating in the electromagnetic field. He demonstrated this by calculating the speed of a traveling wave in his theory, showing that it was the same speed as what had been measured for light. The field or medium which light propagated in was termed ether, because since Thomas Young's double-slit experiment around the year 1800, it had been understood that light behaved as a wave, and the different colors of light represented different wavelengths. This double-slit experiment, which demonstrated light's diffraction, later would be applied to electrons, representing a very important experiment validating quantum mechanics.